Hi, welcome back in this new video. In the previous lesson, we learned how to identify empty columns and correlated features. In this section, we'll see how to deal with those correlated features. So in our case, we noticed that the skin and thickness features were highly correlated. So I'll show you what we did in the previous video. That's it here. We have a correlation value which is 1, meaning that skin and thickness features are highly correlated. So, as we cannot use both of them, I'm going to drop the skin column. So to drop the skin column, so before even trying to drop, let's just have a look again at the data set. So let's show again the first of 5 rows of the data sets before dropping the column. So to drop the column, we can use the delete methods to delete the skin column, giving the name of the column. So applying the delete function, we give the column we want to delete. So we run this instruction. Let's now see again our data sets if we still have this column. As you might notice, this skin column disappeared because we don't have it anymore in our datasets, which means that deletion worked perfectly. So we're going to check for additional correlations. So let's have a look at our correlation again to see if we have any correlations. So here we don't have any highly correlated features in our datasets, which means that um, we're quite ready to create the model in order to train a model for making prediction. So far, we've done good cleanup by removing some columns we didn't need. Now, we need to model the data so that we can use it for training our model. This involves ensuring that the data types and the columns we're trying, the columns are what we need because we cannot use any kind of column in order to train the model, and if required, creating a new column based on existing data. So let's start by inspecting the data type to see if there is any issue. Once again, I will show the first five row. So it's very important to know that the data should be numeric because algorithms are largely mathematical models and they work best with numerical quantities. And in fact, some algorithms require that all the features and classification results are all numerical. So in our case, we still have categorical results, Boolean true and false for the diabetic features. As you might see here, we have true and false. Those values are Boolean values, and the other ones are numerical values. So what we have to do now is to transform these Boolean values to numerical values. So this is very simple. The transformation, to be specific, we need to change true to 1 and false to 0. So this can be done using the map function. We first need to create a dictionary that maps true to 1 and false to 0. The expression can be done with this, the transformation can be done first by creating this dictionary. And after we have this dictionary, what we can do now is to finally apply the map function using both the diabetes feature and the diabetes map dictionary we just created. So we can do that with this instruction. Now, if we run this cell and then once again have a look at our data sets, great, we can see that all the true values have been transformed to 1. We have true here for the first, third, and fifth row. We have the transformation, the corresponding transformation. We have true, all the true values have been transformed to 1, and all the first false values have been transformed to false. So we can now verify the diabetes data type. The transformation worked perfectly because we can see that the changes have been made according to what was specified in the dictionary. So let's check. This will be the final check to make sure everything is correct about and make sure that we don't have any missing values. So the result is obviously false because we used this instruction previously. Now we're going to, we almost ready to use the data for training. However, before we use the data to train a model and make predictions, we need to ensure that the distribution of the data will allow us and then make predictions, because it's not interesting to get to use an imbalanced data set to train a model if we use search an action. If we take such an action, the model will be using will not be very good in terms of prediction. So let's try to have a look in terms of um, percentage of distribution for our data set. To do so, let's have a look at how many true cases of diabetes we have. So we can use that with this instruction. So we have the number of true, that's it. This corresponds to the number of true cases of diabetes we have. Then we can get the number of diabetes for um, the false cases. We get the diabetes columns corresponding which value is equal to 1, and here which value is equal to 0. This one will take all the row and make the comparison if it gets a value of diabetes features which is equal to 1, and it will take the total number of search and observation, search a row, and it will do the same for the first value here which corresponds to 0, and at the end we'll have a total number of positive diabetes and here the total number of negative diabetes. So with that value we can have a percentage, we can count the percentage for true cases with this instruction, and also the percentage of negative cases for diabetes. So by running this instruction, so what do we have? Oh, okay, just solve this problem. So num ops haven't been, so num ops is the total number of data set we have. As you might see here, we have almost 30%, 35% of true cases here. We have almost 35% of true cases and 65% of false cases here. So this is quite a good distribution of true and false cases, which means that we can reasonably train the prediction model using the data we have. So in the next video, we will be using our machine learning models in order, we'll be training machine learning models on our data sets and then be able to make predictions. So stay tuned. If you like the video, comment and like and share. So see you in the next video. Bye.